Hello, welcome to our last lecture of the series. We will be discussing the interplanetary file system and a connection with the smart contracts on Ethereum. What is the interplanetary file system? Essentially, this is a distributed web. It is a peer-to-peer network which essentially can be used to host files or essentially also any kind of website you might want to host in. From the point of view of the construction industry, this infrastructure can help us create common document environments where we can track using cryptography any kind of file across IPFS or within certain containers that we can essentially set up. The file essentially with all of the blocks within it is given a unique fingerprint called a cryptographic hash. IPFS checks for duplications of this across the network and removes them. But at the same time, each network of IPFS stores indexes of and the files they're interested in, but also indexes of where other files might be in. This allows us to create web services and common document environments that do not need a particular vendor to run. So you can establish a building information modeling paradigm using truly an open source and decentralized nature. I'll give you an overview, right? You can install IPFS using the graphical interface. You see here I'm hosting 201 megabytes of files. I have 500 peers, and this is my peer ID. These are the files I have here. If I click on this, this is a file of a school. Let me take a look at the inspection. And the unique hash essentially is this one. I can take this one and save it. Sorry, my computer kind of locked. I can copy this one and then essentially save it onto a smart contract, and through that be able to sign it. So a very easy, very rudimentary common document environment can be created on IPFS in combination with smart contracts. So the way to do that is I already copied the file hash. I'm going to show you the building as well. This is one of the latest CLT buildings that was created in Scotland. It's the largest CLT building in Scotland at the moment, and is located up in Inverness. So again, I go to Files. Copy CID. I'll just stop Blender. And I can go to this simple contract of decentralized BIM I have created, where I have declared a string, and then I have declared three integers that essentially the first one is a serial, which will capture the version of the file, and then I have two other integers where I would like to record performance measures from my BIM software. We won't show this at the moment, but I will essentially show you how you can connect a chains on IPFS. So you see the string which is recorded here is the default I pretend to be an IPFS hash, whereas if I paste here the hash from IPFS, I connect it, and I declare this as number 2. And I'll go back to IPFS, to files. I have another file. Let's see if this is version 2 of the school. I'll copy the CID, and very easy, I will save the new hash file of the file and the new version. And with this very simple smart contract, and obviously without any kind of automation, because you can actually connect IPFS to work automatically with smart contracts, I am able to create a very simple common document environment where I can connect specific files with a presence on the smart contract without actually saving the file itself, so saving me a lot of gas in the process. Those of you that have watched the previous lecture with structs will realize that I can connect the hash and the uint into a struct and actually call them in and declare them in parallel. So for an exercise, what you can do is you can download IPFS and you can use the dbeam difference from file from the CBC2020 as the contract for you to play with. So what I would call you to do is install IPFS, upload a file, hash it, take the hash, and then save it on the blockchain in whomever environment you might be using. Thank you so much for your patience and attention, and I hope I see you in the afternoon to play with smart contracts and Python.